Hi, Dr. Mahisa. Now I'm going to show the benchmarking using CPU-Z. So first of all, I've already downloaded CPU-Z in my laptop, so I can just open it. So after that, it will display interface that shows the details of the computer system, such as the CPU details like the processor name, the code name, and the package, and etc. Also, it will show also the core speed, the cache details, the motherboard details like the manufacturer. For my laptop Dell Latitude 350, the manufacturer is Dell, and the model is 03GP42, and also its bus specs. Also, it will also display the memory details. Now I will show the CPU benchmarking using Geekbench. So I have also downloaded Geekbench in my computer, so I can just open it. We will have the interface of the Geekbench here, and we can just press Run CPU Benchmark. So after the Geekbench has done benchmarking, it will show the results in the website. So for my laptop, Dell Latitude 3520, it will show two composite scores, which is one for single core and one for multi-core. Also, it will show the system information, like CPU information, memory information, the details of the single core performance, and also the multi-core performance. That's it for Geekbench. Now I'm going to conduct this benchmarking on Unity Partition Wizard. So we can choose this benchmark and we can start. So I have two test mode. One is the sequential, which is the one that we are running right now. So this is the result of the sequential test for this benchmarking. And we're going to conduct the random test mode. So this is the result for the random test of this benchmarking. That's it for the Unity Partition Wizard. The task manager, we're going to monitor the background processes and also like the consumption of the CPU memory, disk, and network. So for the low load, the memory consumption is around like 40 to 50%, depends on basically on the background processes and also the RAM. As for the middle mode, the memory consumption will be around 60 to 70%, and by opening multiple applications like C++, game, and also Microsoft Visual Studio that requires more memory access, will consume more memory. As for high load, the memory consumption will be around above 80% or 70-something%. So the high load is like when you open a game software and also multiple applications. So that's it for the task manager. Hi, Dr. Mahesya. Now I'm going to show the ASM code for the benchmarking software. So first of all, this is the program of the project part 2. So for this part is the data segment, which includes all the variables involved in the program. And for the code, first of all, we're going to clear the screen and initialize the variables. After that, we're going to display the welcome message and the polynomial equation that involves. And the coefficient is the birthday dates of our group members, which is 7, 27, 13, and 21. And after that, we're going to prompt the user to enter the number of loops specified they want to execute for the calculation of the polynomial equation. After that, we're going to call get m seconds to capture the first time execution. After that, we're going to calculate the polynomial, and this process will repeat for the number of loops specified. And after this process ends, we're going to capture the second time execution time. After that, we're going to display the results and also the different execution time. Lastly, we're going to ask the user if they want to continue or not. So if they want to continue, they can just press Y. If not, they can press N to exit. Now we're going to move on to example of inputs. So we can try 50 loops. So it will display the results, and we can see that it will also display the different execution time. So for 50 loops, the execution time will be 3532. So if the user want to continue, they can press Y. And now we can try for 100 loops. So apparently the time taken to run for 100 loops is more than the 50 loops. So we can also see the execution time is longer, which is 7051. So if the user they don't want to continue, they can press end exit, and a display exit message will be displayed. That's all for the ASM code for the benchmarking software. Hi, Dr. Mahizia. My name is Lin Xinro, and now I'm going to present about the group project for COA, and it is about CPU and hardware performance benchmarks. So this is our group members, and we are all from section 7. First, we have Chu Chuan Kai, and we have Chu Chen Qing, we have Chen Wenjie Nicholas, and me, Lin Xinro. So why are we conducting this project? Performance is a broad area, and traditional benchmarks cover only part of it. Still, manufacturers use traditional benchmarks in their advertising, and customers use them in making decisions. So it is important to know as much as possible about them. So we're going to use freeware benchmarking tools to explore the specifications of our own computer systems. So the aim of this project is to carry out CPU benchmarking on different computers to make comparisons and analysis. The objectives are to understand the principles of CPU benchmarking, to compare the performance of different CPUs, to analyze the impact of different workloads on CPU performance, and to learn to use free benchmarking tools and interpret their results. So there are 4 computers involved in this project. So we have Dell Latitude 3520, we have Acer Nitro 5 AMD Ryzen 5000 series, and we have Asus TUF F15 and Gigabyte G7 GD. So there are 4 benchmarking tools involved in this project. So first we have CPU tag. CPU tag will show information such as CPU processor, the clock speed or frequency, the cache details, memory details, and motherboard specifications. Also, we will employ Geekbench that will provide 2 composite scores for single core and multi-core performance. And we will also utilize Task Manager that will allow users to monitor and manage the processes and applications running on their computers. And Mini2 partition wizard is used to conduct stress tests for read and write to the external disk.
Alright, so now I will present about the benchmarking result of our projects. The first benchmarking tool is CPU tags, and these are what CPU tags will do. So it actually will collect the specifications of the computers and allows users more details about the specs of the computers. And this actually the benchmarking results, as you can see here, are 3 pictures. About 3 fifths is the CPU, and the main data that we are collected here is actually the CPU processor, CPU clock, CPU cache, and then motherboards, also the general memory. So here are the comparison and discussion among the computers. So actually, we have summarized all the data that we got from the previous slide just now into tables. So here are the tables, as you can see. Here, CPU, the cache, motherboards, BIOS, and the memory. So after we summarize all the data, we actually got to know what is the performance ranking of the computers. So the amounts evaluating the CPU, the cache size, the bus express, and also the RAM. So we have summarized the ranking. So the first one is actually Gigabyte G7 GD. The second one is Acer Nitro 5 AMD Ryzen 5000 series. And the third one is the Latitude 3520. And the fourth one is Asus TUF F15. So actually, yep, here are all of this. So I will now pass my presentation to the next member.
Hello, my name is Chong Kai, and now I will explain about the Geekbench benchmarking tools. These tools is used to measure the performance of the computer systems, such as system information, CPU specification, memory details, CPU single core performance, and multi-core performance. This is the Geekbench benchmark result. Here is the single core performance overall score for the computer, and here is the multi-core performance overall score. And here is the system information for the computer, and also for the CPU and the memory information. Now we go through the overall performance ranking. We notice that the Gigabyte G7 GT stands out as the best overall performance in both single-core and multi-core tasks, making it exceptionally suitable for demanding applications and multitasking. While for the Dell Latitude 3520 offers a well-balanced performance for the user, while Acer Nitro 5, it remains a budget-friendly option for the cost-conscious users. And the last one is the Asus TUF F15. This computer delivers solid performance in specific areas, making it become a choice for users that with targeted computing requirements. For the next one is the Task Manager. This is the Windows operating system tool. It provides detailed information about the computer's performance and the running applications, processes, and services. It can simulate the impact of different workloads such as low load, middle load, and the high load. And here is the example of the Task Manager benchmark result. Here is the low load example, and this is middle load, and here is the high load. And after the comparison, here is the table that shows the differences between the workload of 4 different computers. We can see the significant difference from the Acer Nitro 5 and the Asus TUF F15 from the high load. You can see the Acer Nitro 5 high load is 93% when it's open up to 14 apps, while for Asus TUF F15 it's already up to 94% when it only opened 5 apps. In conclusion, we found that the Intel Core i5-1114 for the Gigabyte G7 GT is the more efficient memory usage across all loads, likely due to the newer CPU architecture and the better system optimization. While for the Intel Core i5, it has a slightly higher memory usage at the low and middle loads compared to the Gigabyte computer. For the next one is the AMD Ryzen 5. This is the CPU for the Acer Nitro 5, which has the efficient at low and middle loads and can handle a large number of apps under high loads. While the last one is the Intel Core i5-103. This is the CPU for the Asus TUF F15. It has an inefficiency memory usage across all loads, possibly due to an older CPU architecture. That's all from my part. Thank you.
Good morning, Doctor. I'm Nicholas Chen, and I'm going to talk about the disk benchmarking process using the Mini2 partition wizard. And this is a stress test for read and write to the external disk. And also we have 2 different mode tests, which is sequential and random tests. Okay, so first is the sequential reading and writing test. So we have 4 KB, 8 KB, 60 KB, and 32 KB transfer size. And this is the chart of the result between the computer at different transfer size for the sequential reading and writing test. And also we have the random reading and writing test. And also we have 4 KB, 8 KB, 60 KB, and 32 KB transfer size. And also this chart shows the result for different transfer size of the random reading and writing test. Okay, so based on the result, we can find that the Gigabyte G7 GD is the overall best performance in all metrics, and also indicating a high performance SSD. And the second one is Dell Latitude 3520, which is also a strong performer, and particularly in random reading, but generally outperformed by Gigabyte G7 GD and Acer Nitro 5 in other metrics. And for Acer Nitro 5, it shows a competitive performance in sequential writing and larger transfer size, but it is lags in the random reading. And for the Asus TUF F15, performs well in random reading, especially at larger transfer size, but generally lags behind in sequential reading and writing. Okay, so that's all for Mini2's partition wizard analysis.
Now I'm going to talk about the ASM code benchmarking for our project. Graph is plotted based on the data. So we can see that as the number of loop iterations increases, the CPU time required also increases proportionally. The CPU execution time scales linearly with the number of loop iterations, maintaining a consistent average time per iteration. So what actually affects the CPU elapsed time? So first of all, it is the increased workload. As the larger the number of loops, the heavier a workload that the CPU has to perform. Each loop iteration involves executing a set of instructions. When the number of loop increases, the CPU has to execute more instructions overall, leading to a longer execution time. Other than that, as the tasks become heavier, they might need to exceed the capacity of the CPU cache, leading to more cache misses and longer access time as the CPU has to fetch data from slow memory. So this is the resource conflict. And too much throttling might also be one of the reasons that it takes more time to execute heavy workloads. Running intensive tasks for longer periods can cause the CPU to heat up, potentially leading to thermal throttling, where the CPU reduces its speed to cool down, thus increasing the execution time.
Okay, so this is the conclusion of our project. The first one is the Gigabyte G7 GD, which is emerged as the top performer, demonstrating superior capabilities across all benchmarks. The second one will be the Dell Latitude 3520, which has a balanced performance and it is suitable for office work and general use. And for the third one is the Acer Nitro 5. It performs well in random write operations and it is suited for moderate gaming and multi-thread tasks. And the last one is the Asus TUF F15. It have a adequate performance for general tasks and moderate gaming. Okay, and now we'll go to the reflection part. So for me, in this project, I learned that every computer performs differently in different aspects due to their own specification. And also I know that every specification will also affect the performance of the computer. And after this project, I have a better knowledge and clearly know the specifications and performance of my laptop after benchmark my laptop. And then I also know that how to decrease the usage of my memory and the CPU. For example, when I using the task manager, I can check the usage of my memory and CPU, that I can end tasks for the useless application in the background, and it will help my computer to perform better. And also from this project, I know the limit of my computer by benchmark my computer so that I will not overload the computer when using it in the future. And that's all from me for this project.
Now I'm going to talk about the reflection on this project. My name is Lim Xing Ro. So through this project, I've boosted knowledge in computer system, benchmarking, and CPU power analysis. I also learned to use tools like CPU ZAG and Geekbench to understand laptop performance metrics. Also, I've utilized Windows Task Manager for monitoring CPU usage by background apps and compared computer specifications with my peers to identify strengths and weaknesses in my machine. All in all, I think I can use this knowledge in the future, like before buying a laptop or figuring out if my current laptop needs an upgrade.
Alright, so now I'm going to present my reflection. So benchmarking actually can provide a quantitative evaluation for system capabilities and allowing user to compare their hardware against other configurations. So we can know which one computer is better and which computer is actually suitable for us. And it actually informs hardware upgrade decisions by highlighting potential performance gains that we can know what performance are actually the computer are. So it's better for us to select the computers to know which computer are we going to buy according to our usage. So it actually also offers insights into the strengths and weakness of the system, so we can know what are the system good at and what not good at.
My reflection from this project, I learned how to benchmark my computer using various tools such as CPU-Z, Geekbench, Task Manager, and the Mini2 Partition Wizard. These benchmarking tools provide a valuable insights into the comparing computer performance and offer detailed information for me through all the analysis. And I also get new experience using the assembly code to benchmark my computer in order to enhancing my understanding of low-level system performance evaluation. And the last one, I also underscore the importance of teamwork as collaborating effectively was crucial for completing the project on time.